Okay, let's dive into a simple but really fascinating puzzle about how machines remember. It's a question that gets right to the heart of how all this precision robotics and automation stuff actually works. So here's the scenario we're going to dig into. Imagine you've got a servo motor. You tell it to go to exactly 20 degrees. It does. Then you kill the power, you walk over, you grab the shaft, you move it to some other random spot. Now, you turn the power back on. Does it snap back to 20 degrees? Well, the answer is a super interesting "it depends." And what it depends on, that reveals the secret behind all high-precision motion. To get to the bottom of this, we've got to peel back the layers and see what a servo motor really is. Because, it's a whole lot more than just a simple motor. Right, so the crucial point here is that a servo is technically a servo mechanism. And the magic word in all of this is feedback. See, a regular motor, you give it power, it just spins. That's it. But a servo mechanism is constantly asking itself a question. Am I where I'm supposed to be? And if the answer is no, it corrects itself. It's basically a smart system that's always checking its own work. So let's break down what's inside this thing. You've got the muscle, that's the DC motor. You've got the brains, that's the control circuit. The gearbox acts kind of like a lever, turning the motor speed into raw power, or torque. And then, and this is the really important part for our question, you've got the senses, the position sensor, which tells the brain exactly where the output shaft is pointing. And this is how that all works together in what's called a closed-loop system. It's like a constant conversation happening inside the servo. The controller, the brain, yells, "Go to 20 degrees." The motor starts moving. And the sensor, the senses, is yelling back, "Okay, we're at 15, 18, 19.9. Okay, stop, we're at 20. The controller sees that the position matches the command, the error is 0, and it cuts power to the motor. That loop is what makes a servo so incredibly precise. Okay, now we're getting to the heart of it. That position sensor, that's the key to the whole mystery. A servo's so-called memory is all wrapped up in this one little component. In these high-performance systems, that sensor has a special name, an encoder. And this little device is everything. You can think of it as the servo's eyes and ears, constantly reporting its exact location back to the control circuit. So what's its job? Simple. It translates the physical spin of the shaft into an electrical signal, a language that the controller can actually understand. It's the translator that lets the brain make sense of what the muscle is doing. And right here, this is where the plot thickens. Because you see, it turns out there are two fundamentally different kinds of encoders, which means there are two fundamentally different kinds of memory. This table right here, this explains everything. On one side, you have the incremental encoder. Think of it like clicking a pen. It only knows that a change happened, a click. It doesn't know the total count unless it's been counting from 0. On the other side, the absolute encoder. This is more like looking at a watch. You know the exact time instantly, no counting required. Now look at that row for memory. For incremental, it's relative. It forgets when the power goes out. For absolute, it remembers. That's the whole ballgame. And you can literally see why they're so different just by looking at them. The incremental one on the left, it's just a bunch of simple repeating lines. The controller just counts blip, blip, blip as the lines go by. But now look at the absolute encoder on the right. Whoa, that's a super complex, unique pattern. Every single position on that disk has its own unique address, its own fingerprint. It's not counting, it's reading. All right, so now that we know all that, let's go back to our original question and finally get the answer. For a servo with a standard run-of-the-mill incremental encoder, the answer is a big fat no. It will not go back to 20 degrees. When you turn that power back on, it has absolutely no idea where it is. So why not? Well, remember, its memory was just a running count of those little electronic pulses. The second you cut the power, poof, that count gets swiped clean. It's like you're reading a book, someone snatches it away, and when you get it back, there's no bookmark, you're totally lost. To figure out where it is, it has to do what's called a homing sequence, like moving all the way to the left until it hits a switch just to find a reference point to start counting from again. But, and this is a huge but, if your servo has an absolute encoder, the answer is yes. Absolutely 100% yes. This type of servo knows exactly where it is no matter what you do to it when the power is off. And the reason is pretty cool. It's not remembering in the way we think of memory. It's simply reading its current position off that unique pattern on its encoder disk. The very instant you give it power, it just takes a look at the disk and knows, I'm at 95 degrees. The controller immediately sees the difference. Okay, I'm supposed to be at 20, but I'm actually at 95. Time to move. And it zips right back to where it belongs. And this quote really just sums it all up perfectly. The position value is always there, ready to be read, even if the machine was moved around with no power. That right there is the core principle of an absolute encoder. Okay, so this might all seem like a pretty nerdy technical detail, but this difference between forgetting and knowing has massive real-world consequences for the machines we use every day. It all comes down to a classic engineering trade-off, money versus capability. Your inkjet printer at home, it uses a cheap incremental encoder. It can afford to take a second to slide the print head back and forth when you turn it on to find its home position. No big deal. But a giant multi-ton robot arm in a car factory? No way. That thing uses an expensive absolute encoder for a very good reason. You can't have it accidentally swinging around to find its position at startup. That would be incredibly dangerous and inefficient. It must know its precise location the very instant the power comes back on. So, the next time you see a robot move with that kind of impossible precision, you'll know the secret isn't just in its strength, it's in its memory. It's this hidden layer of information baked right into its position sensor that enables all the complex and safe automation that powers our world. The fundamental question is always, does the machine know where it is or just where it's been? Because that's the difference between simply moving and moving with real intelligence.
Thanks for watching and grow every day with just a bit of information. Like and subscribe for more content and learning.